In this video, we're going to look at the solution of trigonometric equations using the manual method and also using the TI-84 graphing calculator. We'll do the calculator first. Just two problems here. We want to find solutions in the interval from 0 degrees to 360. So we'll get the calculator, and first of all, make sure that your calculator is set to degrees. So we check the mode, got it in degrees, and then I'm going to enter. You want one side to be 0 here when you do this method. So this is your function f of x, and that's what we're going to be graphing. So it's like you had y equal to that expression. And basically we're finding the intercepts, and from the intercepts, and of course from the intercepts you get the zeros, which are the first components of the intercepts, and that's going to be the solution to this equation. So we go to the graphing section, and I've entered these just to save time here. Selected this first one here, 2 sine x squared minus 3 sine x plus 1. Can't see the whole thing, but that's what I have entered. And then I hit the graph here. Now if you don't get a nice looking graph, go to zoom and do z-trig. In this case it looks like we have a decent graph. We want solutions in the interval from 0 to 360. If you want the complete solutions, of course you just add the period, which in this case of course will be 360 degrees. K times 360 added to each solution you get, where K is an integer, any integer. So what we do here is we want to access the trace function here. So we hit trace, then we just go through the curve. And we're looking for y equals 0 because that's going to tell me it's a y-intercept, or an x-intercept I should say, which will generate a 0. So there you have it. 30, and this of course is degrees, y equals 0. So that tells you that's the solution right there, where the line, where the curve crosses the x-axis. So 30 degrees is 1. And keep going slowly. Just watch the y value until it gets to 0. Now this method is only going to give you the exact solutions, if you have exact ones. Otherwise you have to use another method, which I'll show you in a minute. But let's keep going here. And then we have y equals 0. So that tells me it crosses at that point 90 and 0. So 90 degrees is another solution. Now if you know your reference triangles or reference angles, then you know since we got 30 as a solution and we're dealing with sine, 150 should be a solution in quadrant 2. So let's keep going here. And there's 150. So you got 30, 90, and 150 degrees. Now if we keep going here, just to confirm, see we're getting approaching the x-axis here, but before we get there we get to 360. So there's going to be other solutions over here, because if a trig equation has one solution, it's going to have an infinite number of solutions. It's all you do is add 360 or multiply 360 and you get another solution. But in this case we have all the ones they asked for, 0 to 360. So 30, 90, and 150 are the solutions. Let's go to this. Now the next one is sine 2 theta is equal to cosine theta. So in this case what we do, since the right side is not 0, you should rewrite this as a sine 2 theta, and bring the cosine over. This will be 0. So basically you get to graph this expression here. So this will be your y1 or y2, whatever the calculator calls it. It did 1, so this would be y2. So this is what you would enter in your graphing screen. And when you do the traced, where the y equals to 0, that generates the zeros of that graph, which of course will give you the solution to this equation. We'll go to y equals, and I've already entered that one, sine 2x minus cosine. So I deselect the first one. I don't want to graph that again, so I deselect it, hit enter there. Select this one, and just hit graph. So then we go again and hit graph, there we have it. And then just hit trace. So we start again right to the left of where you see it cross. And go just real slowly. As soon as you see 0, now if you cross that point and it gives you a value, but this is not 0, that tells you it doesn't have an exact answer, so you have to use another method. But for right now, we get that value. So one solution there is 30 degrees. Keep going. And slow down when you get close to the x-axis. And you get a y equals 0. That tells me that 90 is a 0 of that function, which of course it means it's a solution. So 30, 90 degrees. Keep going. And slow down here, we get y equal to 0. 150 is also a solution. Keep going. Slow down, we get close, that's 270. So far we have 30, 90, and of course 150. So 30, 90, 150, 270. Now if we keep going here, see, we already passed 360. But if we keep going, yeah, we get 390, y equals 0. That's another solution. And now we're just adding 360 to the first solution we got, which was 30 degrees. So you keep going, it keeps repeating the solutions. All it's doing though is adding 360 to those previous solutions. So they're infinite. Infinite solution set. But they only want the ones in the interval from 0 to 360. What happens if you get something like, let's say you're solving an equation and you're factoring it out, and you set each factor to 0, you're doing it manually, you get the factor sine of x minus 0.3. So what happens if we graph this one? Let's deselect this equation there. Select this one. And of course on this one you wouldn't have to do it in the graph, because this one, the equation would be sine of x. This would be the, so you have this equation, sine of x is equal to 0.3. Very basic. So here you would just take the inverse sine of both sides, so x would be sine inverse of 0.3. And you would get something like 17.46 degrees. And because it's a positive 0.3, we know there's another solution in quadrant 2 that has this angle as a reference angle. So you simply subtract that from 180 and you get 162.54. But if you're doing just an equation that you're doing strictly on the calculator, and you didn't want to go through the procedure of factoring it out and stuff, and you graphed it, we hit the graph here. There it is. So let's, if we do the trace, we just do trace, you can see that it crosses to the right of the origin there. So we go back here, and we don't get y equals 0. We can guess at the answer or give an approximation to it. So it's around 15, because I just gave you the answer a while ago in the using the calculator. If you keep going this way, slow down here, next to the intercept, we don't get y equals 0, so it doesn't give you an exact answer. And then here we're past 360. So the only ones that we're going to have are right here to the right of the origin, and this one over here. So what do we do in this case? go to the methods and go to the calculate menu second, and then hit trace. We're accessing this menu and we want the 0, so we hit 2. And I could do that one, but I'm going to go to the beginning. So I want the 1 right here where it crosses right there. So once the left bound, I hit enter. Enter. Then I want the right bound, so I go past that point and hit enter. Then it wants a guess. I can ignore that and just hit enter. And you can see y equals 0. So this gives you an approximation. X equal to 17.457 and so forth. And we rounded it off a while ago on the and you do the inverse function on the calculator, 17.46 degrees. 17.46 degrees. And of course, because the angle was in the first quadrant, we know there's a solution also in the second quadrant. But if we want to do it strictly here, we would go again second, calculate, number 2. What's the left bound, so we'll get close to that point without getting on it, and then hit enter. And then once the right bound, so we go past it, hit enter. The guess you can ignore, and then it gives you again 0, and there's your y equals 0. So this is an approximation, so you can round it off. Either 162.54, 2 places, 162.54, and that of course is in degrees. Clear this here. These can be solved easily by factoring. Now there's some of course that you'd have to use the quadratic formula and the answers aren't going to be exact, so probably if the instructor lets you use the graphing calculator, you could get the answers that way. But if you were to solve these manually, and again just to save us some time here, I went ahead and solved them for you here. 2 sine squared x minus 3 sine x plus 1 factors into 2 sine x minus 1, sine x minus 1. Set each factor equal to 0, you get sine of x equal to 1/2. Sine of x is equal to 1. So here you can just use your inverse function, inverse sine function on your calculator. Sine inverse of 1/2 gives you 30 degrees. And again, if you have a solution for sine and it's a positive, in this case positive 1/2, simply subtract that angle from 180 and you're going to get another solution in the second quadrant. So 180 minus 30 is 150. Those are 2 solutions. And of course the other one from sine of x equal to 1, again you can use your sine inverse here. That's going to be 90 degrees. So those are the solutions we got using the graphing calculator. The next one, sine 2 theta is equal to cosine theta. We have an identity that tells me that sine of 2 theta is the same thing as 2 sine theta cosine theta. So we have this now, there. And then we take this cosine over to the other side, adding minus cosine theta to both sides. We get 2 sine theta cosine theta minus cosine theta equals to 0. Again, just like solving quadratic equations, factor out the common factor, in this case cosine. You get cosine of theta multiplied by 2 sine theta minus 1. And of course, if you have one side 0, just in quadratic equations, solving a quadratic, we set each factor equal to 0. So that gives me cosine theta equal to 0. And solve this one for sine theta, gives me sine theta is equal to 1/2. And of course we did this one already. Sine of theta equal to 1/2 has 2 solutions of 30 and 150. And cosine of theta equal to 0 at 90 degrees and 270 degrees. So that's how you would solve these manually. Some get a little bit more complicated. You have to use some identities to solve the problems. But they're very easy to solve if they have exact solutions using the graphing calculator. And even if you don't have exact solutions, you can still get it using the number 2 feature or finding the zeros using the calculator. And of course here we did the answers in degrees. If they ask for answers in radians, I would always just go ahead and find the answers in degrees, and you can easily convert to radians by multiplying by pi over 180 degrees. Thanks for watching. See you next time.